Hello and welcome. My name is Mr. Sportel and I will be your teacher today. This is science class, if you were wondering, not just some random strange dimension of orange things. I've got to unveil the hat of the unit. Here it is. I couldn't actually find a hat, so I found a headband. I have an orange headband. So that's the thing. This is Unit 11. It's the last unit. We only have 3 weeks, and it's going to be wonderful. I just know it is. Because you're here and you're great. So, I'm excited. Let me tell you about the week. This week's going to look a lot different than the past however many weeks we've been doing this. This week is a project. Next 2 weeks will be a whole different project. This week is engineering. Now, typically what happens at the end of May is we do our rocket project. This rocket project is going to look a little different. I know. I'm sad. Some of you are sad. It's always a lot of fun to see people try and shoot a rocket 100 meters across a field. So, what we're going to do is we're going to do our own data looking in on last year's data. I still have the data from last year. So, let me just explain what happens typically. We have this rocket. So, you see there's a 2-liter bottom, there's a 20-ounce bottle on top. You duct tape them together. You got the fins. You make them out of cardboard and you tape them on. Okay? What we do is we're actually paying attention to a lot of different variables. And what we test is a whole bunch of different things. But for us, we're just going to be looking at 6 different variables. And I'll talk a little bit more about those in a second. We're going to go ahead and look at data from last year. And we're going to decide what's the best possible value for each of those variables. And then you're going to look through the data and you're going to try and support your argument based off of the data that you are left with from last year. Then, that's the first part. Then you're also going to be writing about Newton's first and third laws and how you see those in the rocket launching or falling or moving or hitting the ground. So let's kind of walk through this, and then I'll show you the Moodle page you're going to be kind of getting the data from. I'm going to show you the document we're going to be working from, and I'll show you kind of the plan for the week. So let's go to this wonderful page right here. It takes us, here's the link to the project document. Nailed it. Ugh. A little more water for this guy. Last spring, students had to launch a rocket 100 meters. That was their goal. We got a little different goal for us this year. What we're going to do is we're going to see, based off of data they collected last year in their scientific studies, we're going to look at their data and try and see, okay, what's the best value? So, step 1, you're going to log into this Moodle page using the enrollment key 2020. This Moodle page brings you to this wonderful, it's called CP Rocket Data. CP is for Conceptual Physics. This is the data page where all of our classes, Borisma and myself, we all had our data put here. And so different control rocket data. Here's the 6 variables that I left open for you to see. So what you're going to do is you're going to choose 3. I would suggest maybe choosing 1 from each category. That would leave you with launch angle without any choice. But honestly, I'd be happy with any 3 that you prefer. You're going to click on one, click, and it says, oh, all participants. So if it shows up and it's like, oh, just first or just 2020, and it looks like there's nothing there, click on this, go to all participants, and you can see everybody from last year. Hey, look, there's Kyle Phelps. Hey, look, there's Elliot Steelstra. Oh, Cortland Meyer. All kinds of wonderful people who posted their data. Look at all that data. So you can click on it. There's Ross, there's Jacqueline Mulder, there's Will Aldrank, there's Isaiah. So if you want, you just click on one. Let's just click on this one. And it has data tables, graphs that you can look at, and their conclusion, as well as their doc, if you'd like to look through it all. and you got to make a conclusion off of water in the bottom bottle, for instance. So what you're going to do is you're going to write your paper, and you're going to be going through 3 of these 6. You don't have to do all 6. I don't want you to do all 6. I want you to do 3. You'll go ahead, you'll choose 3 variables, kind of whichever ones you prefer. You're going to look through all the data. You're going to take screenshots of the ones that are like most helpful. And then you're going to kind of write out, here is what I think the best amount of water in the bottom bottle would be based off the data. Looking at this person's data, I saw they tested this range and they found this to be an optimum blah, blah, blah. You can look at the number of trials they did and this and this and this, and kind of explain why you think that's a good amount. Then maybe I'll look at someone else's data, and maybe a third person's data. I would suggest having like a table or a graph from maybe 3 different people to really support what you think. Now we think, oh, well, this is going to be obvious. And sometimes it is, but some variables it's not as obvious because it looks like some people's go farther or worse, but they have the same number. That's where this data can be confusing because I'll be honest, sometimes students aren't the best at controlling their variables. So that's where it leaves some ambiguity in what you choose. Just like in real science. Science. What are you going to do? Crazy. So that's the first half of the paper. I would say each variable, I mean, you've got like 3 data tables or like 2 data tables in one graph, as well as like a nice chunky paragraph explanation. That'll easily put you a half a page to a full page per variable. Okay? I mean, you could do double spacing with size 11 font or whatever. But I mean, make sure like you're explaining it well. So that's 3 variables, not 6. Just choose 3. Go ahead, go through it. Choose the helpful, wonderful pieces from it, and then you do like the old screenshot. Throw the screenshot in your explanation. Talk about it. Talk about what you see in the data table. Talk about what the data is telling you. That's the idea. That's part 1 of the engineering project. So that's all explained right here. So that's 3 paragraphs like this, and then you back it up by your data. Then the next thing, you're going to have 2 other paragraphs and another section. By the way, that's worth 10 points. This next thing is worth 5 points. This is where we're going to do the assessment of Newton's laws stuff. You're going to write a paragraph on Newton's first law, which is, do you remember? An object in motion tends to stay in motion. An object at rest tends to stay at rest unless acted on by an outside force. So where do you see that in this rocket launch? Maybe beginning, maybe in the middle, maybe in the end. Like, how do you see it? Then, what about Newton's third law? Do you remember every force has another force that's equal to it but in the opposite direction? Where do you see that? It's the ground at the end. Just an idea for you. Okay, that's 5 points. That's going to be 2 paragraphs. Nice meaty paragraphs that you're going to have at the end. So this whole thing, I'm thinking will be a decently sized paper. I would say probably no less than 2 pages, especially if you're going to put all those data tables and graphs in there. Then when you're done, you're going to export your paper as a PDF. You do that by going File, Download, as a PDF. You're going to turn it in as a PDF. There's a spot on Moodle. Oh, not here because I didn't link it, but the normal Moodle page, like right here. Turn in your rocket engineering data project. I'll link it. Make sure it's available for you. Turn it in here as a PDF. Okay? Make sure it is a PDF, otherwise it won't upload. Now, that's the week. You get the whole week to do this. And I broke it down for you. If you want to follow this wonderful step-by-step directions, you may. You could do just these steps today, just those steps on block day. Maybe you're the kind of person who's like, I like things broken down to small steps. Great. This is for you. Go for it. Do those. culminating on Friday when you write out your last paragraph on Newton Third Law, check over your work, and export, download your documents PDF, and turn it in right here. That would be great. If you're just like, no, I prefer to just spend the hour and a half to 3 hours of my science for the week in one giant chunk on Monday night, and you just like do it and turn it in, great. Do what works best for you. If you have questions, please ask. Go ahead and toss it right up in the little question boxes. Look at all these little question boxes, like this one right here. It's just waiting for someone to write a question. That person could be you. Now, this is going to be great because I know you're going to be awesome at it, because I know you remember what engineering is all about, maximizing an output. So you're going to be looking at this data from my scientists from last spring, and you're going to be trying to come up with, hey, how do I maximize the output for this variable? You're going to make sense of that data because you know data tables. We spent a lot of time with those, and you are going to crush this. That's all I have for you today. Keep checking in this week, see how you're doing. But just remember, you're great, and you're going to do great because you are great. Okay, great. That's all. I'll be done now rambling because it's just me talking to my computer. No one ever really says anything back. It's just like this weird version of class and stuff. So. Done.